This video explains the method to tune a live sound venue with coneq. Instead of only tuning the speakers or stacks in the near field, this method will involve tuning the entire venue in the audience area in order to get a more accurate representation of the frequency response in the entire room. As a prerequisite for this method, you should have an understanding of how regular coneq tuning and measurements work, and should have an idea of the methods and practices involved in doing normal near-field speaker measurements with coneq. This method takes the theory involved in that method and adapts it to be able to find and correct the frequency response of the entire audience area, taking into account the different acoustic effects that the environment would have on the response of the room. When you encounter a venue that is using speaker columns or stacks instead of one speaker, treat the entire column or stack as one speaker when doing your measurements. As coneq does not account for any delay or phase problems, you will have to take care of these issues separately after you have done the coneq measurements and finished uploading all the filters. You need to first familiarize yourself with the sound system that you will be tuning. You should play either pink noise or music that you are familiar with through the system, and walk around the venue to get an image of how the sound is reacting in the environment. You also need to pay attention to each speaker or stack and the coverage that they have. After you have familiarized yourself with the venue, you need to mark off the edges of the coverage zone for each speaker or stack that you will be tuning. To do this more accurately, play pink noise through the system and only turn on one speaker stack at a time. As you walk through the venue, listen for where the high frequencies drop noticeably in volume for each speaker stack. This is where the edges of the coverage should be for that specific speaker stack. Mark the floor at the edges of the coverage with tape so you can easily tell where each speaker stack covers. When you do your measurements for that area, you will be covering the zone within those lines. In addition to the regular equipment needed for doing coneq measurements, you will need a mic boom and some extra cables which are long enough for you to go around the audience area without having to move the sound card. Using the boom is not for the height, but is meant to allow you to hold the mic far enough from your body that it doesn't collect any sound reflections off your torso. The longer cables allow you to navigate your way around the listening area without being restricted by where the equipment is. You can also use a wireless microphone, but make sure the wireless microphone is of high enough quality that there is no coloration from the mic itself. In the workshop software, the main settings will all be the same as with previous tunings with exception to the test signal period length and the stop measurement section. In a larger or more reflective room, you will want to have your test signal periods longer. You select the test signal length in the new measurement window which pops up after you press New. Test different period lengths for different size rooms to get a better idea of what period lengths work well for different sizes. For the stop measurement section, you need to keep the setting on manual. The manual setting means that you will have to turn the measurement on or off depending on when you want it to stop. The method for doing the measurement in a larger venue will be different from a near-field measurement. Instead of just measuring the speaker stack with the paint-the-wall technique, you will be going through the whole listening area coverage of that specific speaker stack. Instead of setting a certain amount of test signals to dictate how long your measurement process is, you will be setting the stop measurement section to manual. This means you will have to manually press the button to start or stop the measurement. You will be walking throughout the coverage area and then pressing stop when you have gotten a clear reading of the entire coverage zone for that speaker stack. You get most of what you can get in one reading, and if any extra readings are needed, then you can use the composite feature to merge those filters together. Put the mic into the boom, and then when the measurement has been started, walk through the audience area from side to side. moving the mic up and down like you are using the paint the wall technique. When you have covered the whole horizontal axis from the distance in the listening zone, then proceed to move a little back and do the same thing back across. Continue this process for the reading until you have covered most of the coverage zone for that speaker stack, and then press to stop the measurement when you feel you have covered enough to get a clear reading. When doing the measurement, be sure to hold the boom away from your body so that the microphone does not pick up sound that is reflecting from your body. This will ensure that you have the clearest, most accurate reading possible. For each speaker stack or column, you need to measure the whole coverage area which that speaker covers. Repeat this process throughout the whole venue until all the speakers' stacks have been measured according to their specific coverage zones. Remember to name each filter file accordingly so it is easier to pick which filters you should be uploading to which speaker stack. Do each measurement at least 2 to 3 times so that you can see if the measurements you are doing are consistent and are an accurate representation of the frequency response in the room. When you are sure that the measurements you have completed are an accurate representation of the room's frequency response, then proceed to use the communication tool to upload the filter files you have to the corresponding speaker stacks. To check if the coneq correction filters have worked or had any effect on the frequency response, use A/B testing to hear the difference first. Then, using coneq, do another measurement of the speaker system while the filter files are turned on. If the correction filters have worked effectively, then the resulting graph in the coneq should show a predominantly flat line. The line may look like it is jagged, but as long as the peaks and lows of the graph are within 3 dBs of each other, the difference in volume is usually not noticeable.